Do a problem from our reader, page 15. It's a simple analysis of like three different competing plans. We've all seen this with like phone plans or rental packages. So we're going to imagine we're off at a skiing vacation. Okay, you realize that you can pay by the hour, $25 per hour of skiing. Or you could join a frequent skier plan where there's an initial fee of $43. That doesn't change, but then you pay only $15 per hour for skiing. And finally, there's the full membership that costs $119 that allows you to ski for the entire day. It's unlimited. Okay, so there are certain times when one plan is better than the other, and we want to use our math skills to figure that out. Clearly, if we just go skiing for like 1 hour or half an hour, we'd want to just pay the $25 rate. If we're going to ski from dawn till the lights turn on, we're going to go maybe with the unlimited plan. What we need to do is figure out an equation to model each of these scenarios. So I've copied and pasted down the relevant information. See if this makes sense to you. $25 per every hour of skiing. $15 per every hour of skiing, but we've had to pay $43 flat rate to get there, or just a flat rate that, notice, H does not appear because it doesn't matter what our number of hours of skiing are. We would just pay $119. Okay, so I then would go to my calculator and I brought it up and I've typed in these equations just to save a little bit of time. Now, once you've typed those in and you've double checked it, I think I've got that right, then you go to the window, and here's where our understanding of domain and range is really helpful, because the domain is my allowed inputs. And so I know I can't ski negative 10 hours, so what do I need to make that? I think I'm going to make that 0, because I could ski 0 hours. Yeah, maybe 10 hours is the most you could do in a day. You get pretty tired. This scale is just what the little measuring ticky marks are on my scale. You can make that 0, or you can usually make it something that's about 1/10 of the entire spread of those data. So that's about right. For the cost then, the least I could pay would be 0. The most I could pay, we know, is going to be a little bit more than $100, so I'm going to make that 125, and then I will make my scale be 25. So that's where those little tick marks are. Now when I graph this, I should see there's my first, second, and there's my third plan. So it gets kind of confusing up here, but nevertheless, I think we can see that one plan goes up like this, and then the other plan just nips off that corner. Okay, so it's really the interesting part is happening up there. So I'm going to zoom in on that part so I can answer the question. I'm going to do zoom box. This is a great feature. See that zoom number 1 right there? I hit number 1, and now I've got this little cursor mark, which I'm going to imagine drawing a window around the parts that are interesting. So I'm going to use my arrows. I'm going to go up, and then I'm going to thumbtack this down by hitting enter. Once I hit enter, it changes to a square, and now I can open up my window by clicking the right arrow, and I can thumbtack any corner. It doesn't have to be the lower left. Then I'm going to open my window, and I'm going to open it just above. I could also go back to my window and type in values, but I like this, it's visual. Then when I hit enter, this is going to be the interesting part. Okay. Now I want to find out where are these break-even points, where are these intersection points, and I can do that exactly by going second and then hit the trace button to calculate, and then I want to find intersect, option number 5. So I hit option number 5, and then look at how it shows this first equation. That's the 25. That's the cursor up there is barely visible, but if I go like this, I'm on that equation. And then if I down arrow, it should jump. There's my other equation. So I'm going to select that one as my first curve. I'll hit enter, and then it jumps to the next one, which, oops, I want it to be the other one. So I'm going to use the up arrow, and then the up arrow one more time. There we go. Now I've made sure that it's on that other line, and I hit enter, and then enter again, and that tells me the intersection is at 4.3 hours. When I'm at 4.3 hours of skiing, I know that those two plans are the same. I'm going to repeat that. I'm going to write that down, 4.3, and then I'm going to do it again. Second, trace is calculate, and then hit number 5, intersect. You can pause me and repeat this, and I'm going to make sure, okay, that's this one. I don't care about this equation. I want to know where does it intersect right there. That's these two lines. So I'll hit down arrow, then I hit enter because yes, that's one of my two lines, and then it jumps to the other line, which I like because clearly that's the other line. I can go along it, hit enter, and there it is after 5.07 hours. So 4.3 hours and about 5 hours, very close to 5 hours, is my other break-even point. All right, so then I would go down and I'd say, under what circumstances is one plan better than the other? Well, this plan is better for less than 4.3 hours. And then this one is better, get in down here, or maybe right up there, better if more than 5 hours. Okay? Anything in between is just that middle plan. All right, thank you very much.